Alright, this video we are going to talk about summarizing IPv4 subnets. Before we talk about how to do it, let's talk about why you might want to do it. If you are entering static routes in your network and you're using a ton of different subnets, you would have to enter a static route for each particular subnet unless you could somehow summarize those subnets and enter one route for that. If you're configuring your routing protocol, we have to put in network statements. So it might be helpful for you to be able to combine all of your subnets and represent them with the notation of one network statement that will cover them all. So there are real reasons why we want to be able to do this. And also, if you're planning on taking any certification exams, there'll probably be some questions about this kind of thing on those certification exams. So I have some sample subnets here, and we're going to talk about a couple of different ways to summarize them. We have 172.16.1.0/24 up to 172.16.5.0/24. So hopefully we all realize that we could very easily type this as a summary for those subnets, but this would include everything from 0.0 to 255.255. So while it would indeed include all of these networks, it also includes a lot more than we want. Does it matter? In many cases it doesn't. In many cases it does not matter. If you're just using these subnets and you're not using 6, 7, 8, blah, blah, blah up above that, it doesn't really matter if you include some extra subnets in there that are not part of the subnet. But as far as efficiency and correct answers in my classes and certification exams go, when you're summarizing the subnets, what it wants you to do is give it the smallest number of subnets possible within that summary. So in this case, we're not going to put /16. The question is, how do we figure out what we need to put? I'm going to show you two different ways to do it. One of the ways is using the block size from that we've learned how to subnet using from the www.learntosub.net site. So if we want to do it that way, we need to figure out the block size that will represent how many networks we have. In this case, we have 5 networks, so obviously the block size needs to be big, the same number of networks we have, or possibly bigger. So in this case, we will have the block size be 8, and for 8 in the third octet, why don't I go to the site and look at the chart so we can talk about that. So if we look at a block size of 8 in the third octet, that's going to give us a prefix length of 21. So I know the prefix length is going to be 21. And then I need to find the place where that network can start. So in this case, the network can start at 0. So that gives us from 0 to 7. So this is actually the correct answer for this particular problem. We need to find where the subnet can start based on the blocks, find the block size that will include the correct number of networks, and find the subnet where that can start. So we have that's the way to do it using the block size. Another way you can do it, which might be easier for some of you guys to visualize, is we can look at this third octet value. We recognize these are all the same in binary, and this is all the same in binary. So what we need to do is figure out where these networks all share a common value. So if we look, I've written that third octet in binary, and what we need to do is find where they all have the same value. And these last 5 bits are all zeros. Is that 5? 1, 2, 3, 4, 5. These last 5 bits are all zeros. So that is where we need to summarize that. The opposite of what I said, these bits are not all the same. We have 1s and 0s in this. So for it to be a summary that includes all this, this is as far as we can go. So if we solve this the same way, or we solve this in the binary way, we need to take this value, translate that into decimal. So obviously, hopefully you know all zeros is 0. So let me make sure I was clear on that. Take this value, fill the rest of the way in zeros, and that will make this a network address. And then we need to figure out the prefix length will be 16 gets us up to here. 16, we have 5 more bits. So 16, 17, 18, 19, 20, 21. So we came up with the same answer. We just solved it in a different way. So that's basically how we do it. I have a couple more examples to talk about some different situations we might run into that we'll solve. So in this case, we have 10.0.130.0/24. We have 3 networks. So if we go the block size way, The smallest block size we could use would be a 4, but we need to see how that works out. So if we go with a 4 for the block size, let me go back to my page. If we go for 4, that gives us a /22. So let's go ahead and write part of this out. 10.0. We'll leave that blank, .0/22. We'll leave that blank for now because we need to figure out where a block size of 4 can start with that. In this case, the block size of 4 starts at 128. So in theory, that is where we might be able to start it, but we need to make sure that it includes all the networks in question. And in this case, we find that by adding the block size and subtracting 1. So if we add the block size, that gives us 132, minus 1 gives us 131. So this network ends at 131.255, which means it does not include 132, which means we cannot use this as a summary for these 3 networks. So if that happens, you need to go down to the next smaller network. So in that case, we'll go down to 128.0/21, and then if we figure out where that network ends, we end up adding 8, which gives us 136, subtract 1, 135.255. So that includes, that is the smallest summary we can use that includes all of those 3 networks. And you might be saying, hey, Rich, well, we're not using 128 or 129, and we're not using 133, 134, and 135. Is that a problem? No, I mean, it's not a problem because we are trying to come up with whatever block of addresses we can use that includes all of these networks. And in this case, this is the block that we have that includes those networks. So I wasn't going to do these in binary because I didn't really want to figure out how to convert into binary while you guys are watching me, but I will anyway, real quickly. So that's 128, 64, 32, 16, 8, 4, 2, not 2, 101 there. So that's 130. It gets easier after that because I can just copy and paste. That's 131. That's 132. So if we solve this in the binary way, we see that these are all the same. So we can write the answer again. It's going to be the same answer. So we'll have 1 followed by 5 zeros, and then we fill the rest with zeros. So that gives us 128.0. And then we figure out how many bits it is, and it's going to be the same we did for the previous example. We have 8, 16, 17, 18, 19, 20, 21. So that's the way you can solve that one in binary if that makes more sense to you. All right, here we have another example of these 2 subnets. So obviously 192.168.4 is all going to be the same because that's where we are here. And we have 32 and 16. So we need to figure out what size network will consume those. And another way you can do this is, figure out where these networks start and end. So this one starts at 16 and goes up to 31. And this one starts at .32 and goes up to .63. So now we need to figure out, okay, what network can I figure out, what network combination can I give that includes all the way up from 0 to 63? And hopefully you'll be like, oh, hey, I need a block size of 64, right? Block size is 64, so that'd be a /26. And then over here, where can that network start? Well, the first network is .16, so I should put that, right? Wrong. That's not a place at a /26 or a block size of 64 that can start. So we have to make sure that we put it at a place where it can start. And that's what that would be. If we want to look at that in binary, I think, let's see, I think this is binary of it. That's not what I wanted. So this would be 32. So we do the same process from before. We have 2 extra bits, so we end up with 8, 16, 24 plus 2 bits makes 26. And then we convert these to decimal with zeros, and then we put all zeros in the host portion, and that gives us the same answer. So that was that. I'm not going to do this last example I wrote out because I feel like this has already gone on longer than I wanted it to. But that is pretty much the idea behind how to figure out and solve these subnet summary type questions. So, if you have any questions, let me know.